homework. The following stem and leaf displays the marks a group of students got in a maths test. How many students sat the test? So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. And I think that's right. Let me check it again. 4 plus 6 plus another 6 plus 2, 4, 6, 8 plus 4 plus 3 plus 2. Yeah, 33. Highest mark. Now, because you know how stem and leaf plots are formed and they're all in numerical order, the highest mark is this one, okay? Which is a 0 in the leaf with a 10 in the stem. So that's 100%. Okay, it tells you down here that it's a percentage. And the lowest mark is going to be the 1 here. But again, it's not just a 1, it's a 1 in the leaf paired with a 4 in the stem. So that's 41%. How many students got a mark of 72? So if we want 72, we have to look here in the 7s. And there's 72 and there's another 72. So 2 of them. What is the difference between the lowest mark and the highest mark? So the highest mark was 100. When they ask you for a difference, that means you're subtracting. Lowest mark is 41. Now there's a name on this, which we'll come across later. So the difference there is 59%, and that's actually called a range. Don't need that for here, but you will need it later. Okay, so when you do the highest mark minus the lowest mark, it's called a range. Here are the marks obtained by 20 students in a maths test. Use the data from the table to complete a stem and leaf. Okay, so we'll do our rough stem and leaf first, and then we'll do our accurate stem and leaf. Okay, so stem. Smallest number, 32. Yep, the biggest seems to be 100. So 3, 4, 5, 6, 7, 8, 9, 10. Lengthen this line a little bit. There you go. Okay, and then the leaf over here. Okay, so we have 70, 86, 100, 52, 71, 57, 72, 86, 32, 40, 46, 61, 72, 76, 89, 77, 98, 86, 46, and 48. So 1, 2, 3, 4, it's 5 across 4, so it's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I think I have them all. So I'm just going to do the proper version of it. Could do it here maybe. Okay, so I have the stem here and the leaf here. So 3, 4, 5, 6, 7, 8, 9, 10. So 2 is fine. 0, 6, 6, 8 is fine. 2, 7 is fine. 1 is fine. God, it's nearly all fine. 0, 1, 2, 2, 6, 7 is fine. This needs to be changed. It's 6, 6, 6, 9, 8, and 0. Very little change there. Now the key. These are the marks obtained by 20 students. Okay, so 8 line 6 is 86 marks. Yeah. And then what percentage of students achieved a mark greater than 50%? Okay, so greater than 50%. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 students. Sorry, did better than 50%. Now remember, when you're getting a percentage, you have to start with a fraction, so it's 15 out of 20. That's your fraction, and then to make it a percentage, you times by 100, and 15 out of 20 is 3/4, which is 75% as a percentage. Okay, so that's stem and leaf, so mark them. And then we're moving on to our last chart, actually, which is a histogram. Now, okay, so a histogram is used for continuous data, okay, so continuous numerical data. So remember, continuous data is the one with units, okay, like height, because it could be measured in centimeters or meters, weight, grams or kilograms, temperature, because degrees Celsius, etc. Okay, so all of those ones. Histograms are very similar to bar charts. There is a massive discrepancy between histograms and bar charts if you do histograms kind of to their complete form, I suppose, but you know, it's not on your course. It says it here, look, on our course all the bars in a histogram are of equal width. Okay, so there is a way in which the bars on a histogram can be different widths, and that makes them obviously very different from bar charts, but we don't have to study that. Okay, so essentially the only difference between a histogram and a bar chart on your course is that there are no spaces between the bars. Okay, everything else is the same. So if it's a histogram, there are no gaps. Your bars have equal width, but there's no gaps in between them. If it's a bar chart, your bars are equal width and there's gaps between them. Okay, so let's have a look at this one. A supermarket opens at 8 a.m. The histogram shows the distribution of times employees arrived at work on a particular day. Now, because this is continuous data, you'll always have this little thing down here. So see the way it says first bar goes from 7:20 to 7:30. That includes 7:20 but excludes 7:30. Okay, so the people who arrive in this bar are arriving between 20 past 7 and like 29 minutes past 7. If you arrive at 7:30, you fall into this bar. Is that okay? So it's kind of, because it's continuous data, they look like they run together, but there has to be some kind of a proviso that tells you what happens if you're bang on the 7:30. Do you go into this bar or do you go into this bar? Okay, so that's what this says. The 7:20 to 7:30 bar includes 7:20 but excludes 7:30. So if you arrive at 7:30, you will fall into the second bar. If you arrive at 7:40, you fall into the third bar, and so on. Okay? So how many employees arrived before 7:30? So that's that first bar there. So 3. How many employees arrived at or after 7:30 but before 8 a.m.? Okay, so these people arrived between 7:30 and 7:40. These people arrived between 7:40 and 7:50, and these people arrived between 7:50 and 8. And remember that 8 is not included. The people who arrive at 8 go into this bar. So it's these 3 bars, which is 4, 8, is that 5? And 5. So that's 17? 13, yep. How many employees arrived for work on this particular morning? So 3, 4, 8, 5, that's a 2, and that's a 1. 12, 15, 20, 23? 16, yeah, 23. What fraction of the employees arrived no sooner than 8? What fraction of the employees arrived no sooner than 8 a.m.? Okay, so they're the people, that's weird language, but no sooner than 8 a.m. That means they arrived after 8 a.m. So it's these people and these people. So 3, and it's a fraction, so it's 3 out of 23. I don't know why they're using that weird language there. So that is what fraction of the employees arrived no sooner than 8 a.m. So that's arrived after 8 a.m., which is 3 out of 23. Okay. Right, so the following frequency table shows the times in minutes spent by a group of people in a museum. And again, here you always have this for histograms. 10 to 20 means 10 or more, but less than 20, and so on. Okay, so if you're in this section, it means you stayed for between 10 minutes and 19 minutes 59 seconds. But if you stayed the 20 minutes, you go into this group. Yeah? And we need to represent this on a histogram. So again, you draw it very, very similar to a bar chart. Okay, so your line up and your line across. Same as the bar chart, this is the one that's going to change. So in this case, it's time. This one here will always be frequency, okay? Or in this case, number, but it's the same thing. Okay, so let's see, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, so plenty of room. And we have room here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Close enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then this is 0 to 10, then you 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Yeah? Okay, and our first bar, 0 to 10, goes up to number 1. Did I get that? Oh, I did. There you go. Second one, 10 to 20, goes up to 4. Here's 4. Okay, and remember the bars have to be the same width, but no gap between them. 8 next. No, insert. So 8 is here. Uh, 7. Oh, sorry. Did I hit the wrong thing there? So insert 7 is there. And 9. Okay, it's kind of hard to tell exactly where 9 starts, but about there. Close enough, it's a little bit off. All right, so that's my histogram. Okay, so when you're drawing them, like I said, pretty much identical to a bar chart, just don't leave the gaps, okay? Because it's continuous data, they run into each other. So like I said, it's 0 to 10, 10 to 20, 20 to 30, so there is no gap, okay? Because it's numerical data and it's continuous numerical, whereas a bar chart is normally for like the colours of cars or something. All right, so that's histogram. And I have 2 questions for homework. I think one where you need to take the data off the chart, and one where you have to draw the chart. Okay, so pretty much like what I just did. All right, and that's due for Monday.